Hi math students! In this video we're going to have an introduction to solving inequalities. There's a video that comes before this one that's just an introduction to what inequalities are, what symbols we use, what they mean, and how to read them. So if you're looking at the board and you're not sure how to read this statement, when I say negative 2x is less than or equal to 10, if you're not sure if it's less than or greater than, then go back and check out the other video called Introduction to Inequalities or Intro to Inequalities. And in that video, I'll be able to go into more detail about how to read these statements and use the symbols of inequalities. In this video, we're going to focus on solving. All right, so there's a couple of keys to this lesson. One is that solving inequalities is it's a very similar process to solving equations. We're using properties of equality to do it. So if you know how to solve one and two step or multi-step equations, then solving inequalities will come very quickly to you. If you're not sure about solving equations, then go back and check out these other videos like solving one-step equations, and definitely recommend these two about equivalent statements and properties of equality. And that will help to build up a lot of the background knowledge that you would need. A lot of the things that I'm going to reference in this video come from those videos, okay? All right, so assuming that you know what I'm talking about when I say properties of equality or equivalent statements, then there's a couple keys to the lesson. One is we're going to be using the properties of equality to solve, okay? Second is the only difference between solving an equation and solving an inequality is that whenever you multiply or divide both sides of an equation or an inequality by a negative number, you have to change the direction of the inequality. Or as my colleague likes to say in the math department, anytime you divide any mathematical statement by a negative number or multiply both sides by a negative number, you change the direction of whatever symbol that is, even if it's an equal sign. Okay, so let's look at a few of these examples here, and we'll build up some background knowledge and then use that over here to solve these more algebraic looking statements. Okay, so here we have 10, this statement says 10 is less than 20, which is a true statement, okay? So this is starting off as true. 10 is less than 20. And the reason I wrote these 6 little examples over here is to kind of just illustrate what the properties of equality are doing. So the property of addition property of equality says that we can add the same number to both sides of a mathematical statement, and we will get an equivalent statement. In other words, we'll get a statement that has the same solutions, okay? So what I am going to show is that we can add any number we want to both sides of this statement as long as it's the same number, and we will still have a true statement. So let's just pick 5. If we add 5 to both sides of this statement, then we'll have 15 is less than 25, which is also a true statement. So it maintained its truth. Let's try the same exercise for subtraction. Say we subtract 5 from both sides of the statement. Well, then we get 5 is less than 15, which is also true, right? We started with a true statement, we ended with a true statement by using this property of equality. For multiplication by a positive number, say we pick 2, right? If we multiply both sides of this equation, this inequality by 2, we're going to get 20 is less than 40, which is still a true statement. And finally, if we divide by a positive number, say we divide both sides by 2, we started with a true statement, we're going to get 5 is less than 10, we ended with a true statement. So no problem using any of the properties of equalities for anything here. The problem happens when you try to multiply by a negative number or divide by a negative number. So let's look at what happens. Say we have this true statement, 10 is less than 20, and we multiply both sides by negative 2. So if I multiply here by negative 2, multiply here by negative 2, what we're going to get is negative 20 is less than negative 40. And that is a false statement. Negative 20 is not less than negative 40. Negative 20 is greater than negative 40. If you look at the numbers that are on the number line, the numbers that are on the right are the bigger ones. This one, negative 20, is to the right of negative 40. This is a bigger number. So this statement is false. So what can we do to remedy the problem? We can just change the direction of the inequality, right? If you change the direction of the inequality to say negative 20 is greater than negative 40, now you have a true statement again. Okay, and the same problem happens here. Say we divide both sides by -2. We'll get -5 is less than, oops, there we go, -10. And that is a false statement. -5 is actually greater than -10. So to fix the problem, what we do is change the direction of the inequality. So it should say -5 is greater than -10. And so that's, which is a true statement. And so that's the reasoning behind why when you multiply both sides or divide both sides of an inequality by a negative number, you have to change the direction of the inequality to maintain the truth of the statement. All right, let's try and solve some of these more algebraic looking statements. So start with this first one. It says, a number plus 3 is greater than -5. Okay, well, if that was an equation, how we would solve it is we would isolate x, move things away from x, right? So if we move this +3 to the right-hand side, using the subtraction property of equality, we subtract 3 from both sides of this statement, then what we would get is x is greater than -8, okay? Now, let's take a second to think about this. So first of all, this is a statement that could be true depending on what value you choose for x. And what this is telling us is that if you choose any value for x that is greater than -8, so for example, -7.999999 would work, or -7, -6, 0, 1, 2, 3, any of those would work, right? Then the statement becomes true. If you choose any number that is -8 or less, then the statement becomes false. And these two statements are equivalent to each other. Since we used the property of equality, we created an equivalent statement, and equivalent statements have the same solutions. So if this one has, if any value of x greater than -8 makes this one true, then any value of x that is greater than 8 will make this statement true. All right, now one other thing to point out about this is that there are a lot of numbers that are greater than -8. So there are an infinite number of numbers that are greater than -8. So there's an infinite number of solutions to this statement. Pick a number that's greater than -8. You could spend the rest of your life picking numbers that are greater than -8. There's infinite number of solutions. Or in other words, there's an infinite number of numbers that make that statement true. Now I want you to take a second to compare that statement with this one. X plus 3 equals 5. The difference between an inequality and an equality, right? Equation. We solve it the same way. Subtract 3 from both sides. And with this time we get x equals 2. There is only, now these two are equivalent statements. The solution to this one is the same as the solution to this one. There is only one value in the entire universe of numbers that makes this statement true, and that is 2. X has to be equal to 2 in order for this statement to be true. So here we have one solution, an equation that has one solution. But a very similar looking inequality has an infinite number of solutions. Something to keep in mind. Okay, let's have a look at a few other ones. Here we have solve -2x is less than or equal to 10. Okay, use the division property of equality. We'll divide both sides by -2. And what we learned over here is that whenever we divide both sides over here, whenever we divide both sides by a negative number, we need to change the direction of that inequality in order to maintain the truth of the statement. So here, when we're dividing both sides by -2, this inequality should now be facing the other direction. And we'll have x is greater than or equal to -5. And there's our solution. An infinite number of solutions, as long as you pick any number that's -5 or greater, that will make this statement true. Now, I put the next example because it's very similar to this one. But in the process of solving, there's a subtle difference that you should be aware of. Here, when we're trying to isolate x, we're not dividing both sides by a negative number anymore. We're dividing both sides by positive 2. So if we divide both sides by positive 2, then there's no need to change the direction of the inequality. We're dividing both sides by a positive number. Even though this number over here is negative, we still don't need to change the direction of the inequality because the number we're dividing by is positive. We're dividing by a positive 2. So the result of this one will be x is still less than or equal to negative 5. Okay, so the value of the variable that makes this statement true is any number that is negative 5 or less. And then if you contrast that with this equation down here, where we would divide both sides by 2 and get x equals 5, this equation only has one solution in the universe of numbers that makes it true, just 5. All right, I hope that helps to put some of the pieces together. Thanks for watching. See you next time.